Hello, so today we are going to do this Leetcode day 19 problem, which is search in a rotated sorted array. So we have this array, it's sorted originally, but it's rotated. So here, for example, it's rotated at position 2, and so we get these at the beginning and then these at the end, and we are given a target value to search. If found in the array, we want to return its index, the index of the target value, otherwise we should return -1. And we might assume that no duplicate exists in the array. And our algorithm has to run in overlap in time. So let's see how we can solve this. Okay, so we have an array, it's sorted, and we just need to find some function, right? So we can do this in 2 steps. So the first step can be find rotation position, right? And then step 2 can be for us can be finding the value, find the target position. So the first step is to find the rotation position. So how can we do that, right? So rotation position, what is the property of that? We want something that can give us a function that has these values like this. So something like this. So here, rotation means basically, if we have something like this, it's the first position where basically element I, right, is bigger than the next one, right? So that's the rotation position. And then once we find that, so let's say find rotation index. So that would be the first step, and this would be in this position. Then from there we could search from 0 to that position, right? We could search in this array since it's sorted, binary search there, and we could binary search on the rest. So at that point we could just binary search for if, depending on whether, if the target value is smaller than 7, well, actually smaller than, if it's bigger than, well, actually if it's bigger than the last value, then we should search in this half. If it's smaller, we should search in this half, right? So if target is smaller than the last value, then we should binary search. Well, another way to do that in a way that where we are very sure of it is, so we know the position is I+1. So if it's between this and this, then we need to search from I+1 for this array all the way to the length of the array. Otherwise, well, we should search the reverse, right? The other way to do this is to check if it's between 0 and just I. This is easier to understand. And then here, we want to go from 0 to I. And then that means we need to define binary search here. So the way we can do that is have a function like this. It gets, we don't need to pass the array, just pass the indices. It gets a low and a high value, and we do binary search. So for that, we need to do mid I think it's that. Yep. The other way to do it is just low plus high minus low divided by 2, right? Okay. And then we are going to check here if, well, what do we want for the step 2? So it's less than or equal, and we want the last value that has that, right? Target. So this way we will keep getting false and then we'll start getting true. Okay. And once we start getting true, which means, sorry, actually what we want is bigger. So once we start getting true, we will never not get a true value because it keeps increasing. Otherwise it's smaller. So if this here is bigger than target, we wanna go, so if it's bigger than it's true, so we're gonna go left, right? So go left to find possibly a better value, right? So at that point, going left means setting high to a lower value, right? So, and potentially mid is the exact solution, so we'll leave it like that. Otherwise, we want to go right. So if it's false, which means it's smaller, we want to go right to be able to find a solution. So to do that, we are going to say mid minus 1. And then we are going to return mid. We're going to return low. And hopefully that would work. Now we need to define find rotation. But yeah, so we need to find rotation here, which say takes the array. And a way to we can do this is we want to find something that has this property. So what is the function here? It's also the value that is smaller than this, right? So we are also looking for array I that is smaller than array 0, right? And this property here, well, it will be false here, right? Because array 0 is not smaller than array 0. So these will be false, and then we'll get true, and once we'll get true, we'll keep getting true, right? So this is what we are looking for here. So we're going to do that here. This would be mid, and this would be similar. So if this is the case, we need to go left in order to find. So if this is the case, then maybe we are here and we need to go left to find a better thing. And so to do that, otherwise we can go right here. So otherwise we should go right, because if it's bigger or equal, then maybe we are here. We need to go right to find the rotation index, or here, right? And we could return low there. Okay. So with this at the end, what should we return? Or when a return is the index that we found. So that means that here we return either this or this. So we have here, so what would be, this would be 0, and then the length of the array minus 1. So it seems like it didn't exit. Okay, let's see where we have the problem. So let's take just this here, this sorted array, and let's just first here, before calling any of this stuff, return 0, and what we want is just binary search on this array for value 4, for value 6, let's say, and let's return that. So 0, 1, 2, it should say 2 here. Yep, so this is the problem here. Okay, let's pass these. This is easier to do. We are going to say something like this, and this would be so let's say target is equal to 6, and let's go from 0 to 4. Okay, so binary search here is not working. So when we go left, so we are putting high to smaller. Okay, I think here I'm making a mistake, so I want to go past it now before. Same thing here. Okay, so that looks better. Let's try to see if this no longer times out. Okay, so the value here is 5 for some reason. Yeah, it may be rotated at equal, right? But that's not the case here, definitely. Yeah. One thing I want to do here is just make sure that the position we got is correct. We might not need this, but I just want to make sure. So only if it's equal that we return this, otherwise we say we didn't find it. So right. Here, is this enough? So we want it to be smaller than array 0, but it should be smaller also than the last value, right? So here, and smaller than. Okay, so let's binary search here, and another thing we want to do is here, in case we have an array of equal elements. Okay, that looks good. Let's try with this and target 3. Okay, what if we had a sorted array? 2, 3, 4, 5, 6, and we were looking for 3. Still works. Let's try to submit. So this is with an empty list, right? So here, this is looking for a target, so we should say if not nums, just return -1. Okay. So if it's sorted in decreasing order, you can't find it, right? I think this is something we should check. We want to find something like this. So binary search between 0 and 1 for, well, target is 3. So binary search, so here it seems like, let's see in which one it went. So target value is 3, so it's smaller than 0, but so 2, it went here. And so we will be looking in 1, and the length is just 2, 1 and 1, right? So low and high would be 1 each. And so here, let's print low equal to this, and let's print the value here for this array value. So that gives us this. right? Okay, so the element is 1. It's not 3, which is what we are looking for. The problem seems like to be this. So we need to first check on this first. So here, num0, this is 3, target is 3, and this value is 1, which is not the case. That's why it went here. So we need to make sure that, so we need to do something else here. Okay, so I think what we should do here, let's try to do this check here differently. So what I want to say is that if the number at the last position, if target is small at the first position, is if this is smaller, then we should look at the second half, right? So we should do something like this. Else we should look here instead. That way it's easier. Okay, looks like that's good. Let's try with these. Okay, looks better. Split. Get rid of this one. Okay, so when it's sorted, we have a problem also. Okay, so when it's sorted, we could solve this easily. Basically, if this number here is smaller than the one at the end, or of course equal, then we could just return, or just go with smaller. It's binary search for 0 until the end, right? Which is n minus 1. Okay. Okay, so that's accepted. Cool. Yeah, there are a lot of edge cases here, but the main idea is binary search to find the rotation index, and then binary search to find the element itself, and use this technique here of identifying the function that will give us this pattern. And yeah, that's pretty much it for this problem.